we've got our 12 drawings now of our ball descending and springing back up again. So it's numbered 11, but we've got that 7A in there, which gives us the 12 drawings. So there's our overall action. What we want to do now is we're going to add on a second ball on top. It's going to be slightly smaller, and this ball is going to overlap in its action, meaning that it's not going to be moving at the same time. Overlapping action simply means not everything happens at the same time. So while our ball is bouncing up and down like this, on this type of a timing, what we want to do is we want to delay the second ball by having it drag and hang, and then it catches up and comes down, so that when this one hits and comes back up, this one squishes on it and is forced back up, so that when it reaches the high point, this one's still going up while this one comes back down again and it catches up. So we've basically got this overlapping action on top of each other. Right? If we put them off to the side, this one would drop first and then this one would drop. And so we'd have this type of an action taking place. But what we're going to do is we're going to place it right on top, so we have an action-reaction as well. Okay. Now, the top ball, or this ball that we've drawn from last week, is going to become what's called our primary motivator. It's the part of the body, or in this instance, the ball, that is actually causing the action to take place. We'll say it's the heavier ball. The secondary ball that's on top becomes secondary action. So primary, secondary. It's just going to follow along with what this ball does and react to it. All right? So, if we take our drawings back out, and we start with drawing number 1, this position is at the very high point. Right? It's just starting to come down. It's frozen in frozen in space at the high point, and then it drops down, speeds up, hits the low point, squishes, recovers, comes back up, stretches, and recovers back to its circle point and reaches the high point and then comes back down again. It's not actually frozen at that point because it's only exposed for 2 frames, which is what everything else is exposed for. So it's like saying, well, the middle drawing is frozen in space. It's not frozen in space. Right? So this is both the high point where it stops and starts to come back down again. It's the extreme position. Right? So that's why we call it a keep. It's the extreme point that it goes up and then it returns back down again. Now, when we go to draw our ball on the top here, what shape would that ball be? Anybody have any ideas?
Like 7?
On drawing number 1.
Yeah.
Like 7?
You like 7?
Like number 7? Let's see what number 7 is.
So
Number 7 is just the squish ball.
Squish.
So it would look like that?
Yeah.
Okay, what's
It's
this?
the first ball.
But what is this ball doing?
going down,
Is it going down or is it coming up?
going down.
Well, it's doing neither. It's actually stopped at the high point
So
and it's
the
about to
ball
come down. So it has
already-
just gone up and it's about to come back down again. So what would the other ball be doing?
Just about to hover, so maybe it'd be the same.
Just about to what?
Just about to hover before this ball is about to fall down, so
Well,
it'd be
the drawings just before this one would be 9, 10, 11. So it's on its way up.
So make
And it's just about to come back down again. The answer actually is, we don't quite know at this point. It could be a number of different things, but we don't really know, right? Now, when the ball drops, as it's falling from its high point, it drops down and it reaches its maximum speed at drawing number 5. That's the falling position. I think that's the drawing that we should start with. So pull out your number 5 drawing. So number 5, it's the circle. It hasn't deformed or anything like that, but it is dropping and it's reached its maximum speed at this point. It's not going to go any faster than it's going right now. So it's safe to say that the ball that's above will most likely be in a stretch position because it's being pulled by the bottom ball. So therefore, we can draw this ball in this position here, stretched out. So what I want you to do, you can overlap it a little bit if you want to, but you don't have to. You can just have it touching. I want you to draw a slightly smaller stretched ball.
Right.
Yeah,
I just get my-
yeah. Just a slightly smaller stretch ball right above it like that. So the bottom ball is falling, it's dragging the top ball, so it's going to cause it to pull and stretch. Now that depends on how much you want it to happen. I mean, we could exaggerate this if we want to, or we could lessen it if we want to. It just depends on how much effect you want to have it being caused. But we'll draw it basically like this just for the sake of making it look obvious. Now, when we're dealing with overlapping action or something that is happening because our primary motivator is doing whatever it's doing, this one is just simply following behind it. We're not really able to find any key positions for it because all the action is delayed by a certain number of frames. It could be one drawing, it could be two drawings, I shouldn't say frames, I should say one drawing, two drawings, three drawings, four drawings. It just depends on how much you want to delay it. So let's say, for instance, my one finger here is the primary motivating ball. It's the ball that we've just animated. And it's going down like this and squishing and bouncing back up. So it's doing this, right? So my drawing right after the high point is the next one coming down. It was number 2. It was just a little bit of a movement. So I can make this finger stay at this point here, and then it starts to move when this one comes down to its next drawing, number 3. Then this one starts to move a little bit. Then this one goes down a bit more. Then this one moves to number 2. This one moves to number 5. This one moves down to number 4. Okay, so there's just one drawing overlapping, and so you're going to get this type of an action. However, what I could do is I could go 1, 2, and then this one starts. And I get more of an overlap where it's overlapping like this. Or I could go 1, 2, 3, and then this one starts. And I get even more of an overlap where it's like this. If I overlapped it at drawing number 6, it'd be, this one would be at the high point, this one would be at the low point, and it'd be doing this. Okay, that would be the overlap. It's a complete opposite position, right? So depending on the number of drawings that you choose to overlap something will cause it to delay more. So in this case here, we're going to delay it maybe 2 drawings. And again, this is something you can decide later on. But we definitely know that within the action of this ball dropping, that this ball will definitely be stretched. Now the point here that I'm trying to make is that when we're doing overlapping action, we always draw straight ahead. In our previous version, when we did the perpetual ball bounce, we found our key position, the high point and the low point. Right? We had to find those key positions. But in this case here, because it's simply following what the primary ball does, we simply follow the action as it's being done. And so we just do drawing one after the other. We don't go with the keys, we just do what's called straight ahead animation. So now our next drawing after number 5 is number 6. We pull this one out. And the ball is essentially acting exactly the same way as it has in the previous drawing in number 5, right? There's no difference in this ball here other than it has just touched the surface of the ground, but it hasn't deformed at all. So therefore it would be safe to assume that the ball on top would be basically the same in this drawing as well. It's just dropping, it's being pulled. What we could do is we could stretch it just a little bit further, right? Because it is still accelerating from the previous drawing in number 4, which was slightly higher, half the distance in between these two, and then the next one, it goes double the speed. So therefore we could stretch this drawing out a little bit more, or we could leave it the same if we wanted to. Right? So let's just try stretching it out a little bit more. So we'll do the shift and trace method where you put it right over top of the primary ball, and I just want you to stretch this one just a little bit more. Maybe about 1/8 of an inch. So that when you flip the 2 drawings, it looks like this. See how it pulls just a little bit? So the bottom ball is in the exact same position, but the top one has the appearance that it's stretching out just a little bit. Now what this will do from a visual illusion point of view is when we go from this drawing to this drawing here, it'll look like it's being pulled harder, which means that we're actually creating the illusion that that space that we created for the bottom ball, it is physically going faster because it's going a greater distance. So therefore we have to manipulate the top ball in order to create the illusion that it's actually pulling the top ball and stretching it out because it is going faster. And that's why we choose to stretch it a little bit. Okay? If we didn't stretch it, it would remain the same and it wouldn't have that same illusion of speed. Right? So we're creating these little visual optical illusions by doing this. I mean, just the act of doing this is an optical illusion. We're creating the illusion of movement, just because it's going from one point to another. Now, by distorting the shape of the ball, we're creating the illusion of speed and distortion. Now, when we move to number 7, here's where the ball has squished. Okay, so now it's decelerated from the distance between number 5 and number 6. Okay, it's gone its maximum distance there, and you can see that between these two here, it's minimized the amount that it's actually moved. It's a tiny little distance, so based on this distance here, it's quite a bit greater, and we've got that little tiny distance there. That's because it was the favor. Therefore, the speed has decreased dramatically. The distance has decreased dramatically. And so therefore, we're going to get an effect where, because this ball has squished, the top one is also going to impact on it as well, and it's going to distort as well. Now, what we could do here is one of two different things. We could leave the ball stretched out, okay, if we wanted to. It would have to compress slightly, or what we could do is we could return the ball to a full circle here, which would be like halfway between the stretch position, and in the next drawing, when it returns back up again, basically the top ball is going to squish over top of it because the forces are going in opposite directions. The top ball is still going down, but the top ball's, or the bottom ball is going up, and it's going to flatten the top ball out. So therefore, we could go to a circle position in this one and probably be safe. Okay. So just draw it as a circle there. And so what ends up happening is we get this effect here, where the bottom ball squishes, the top ball returns to a circular state because it's no longer stretching, it's deforming back to its normal state. And then in the next drawing, as number 7A goes back up again, it's going to compress the top ball down on top of it. So what I want you to do here is smush it down like this. Over the top of it like that.